This is Decoding Learning Differences with Kimberlyn Lavelle, and this episode is Addition Strategies Across Grade Levels. This episode is going to be a bit of a big one as we go through the different grade levels, the different strategies, and the concept of addition and how it progresses across the ages. And I will be emphasizing the same things over and over about always starting with concrete, then moving into pictorial, and then into the abstract. A lot of times we're jumping into the abstract way too quickly, and it can cause kids to look like they know what they're doing, and then it gives them a lot of difficulty later on. So a huge piece of advice when you're teaching math concepts in general, make sure that you're going as slowly as needed and really making sure the kids understand it early on so that later when they're presented with a more complex version of it, that they really understand it so well that it's not a big deal and they're able to move through it smoothly. So before kids even start adding anything, there are some pre-adding skills, I'll call them, that they need. They need to be able to count, and that counting needs to be with one-to-one correspondence. So that, meaning that if they count, they can actually count objects, right? They can say 1, 2, 3, 4, and be accurate. So beyond just saying 1, 2, 3, 4, 5, that they can actually count objects and be accurate with their counting. And number recognition is definitely necessary before they can do any addition problems in the level that we would call abstract, where it's just numbers and symbols. 5 plus 2, what does it equal? They have to recognize what a 5 means, what a 2 means. So they have to have those skills first. Then early adding. Kindergarten, first grade. So they will be adding up to 5 in pre-K usually. But the overall thing is it doesn't really matter about the grade level so much. It's just the kind of the order of what you're looking for as you're approaching it. So if your child is really young, hasn't done any addition at all yet, this is what you're thinking about is first you want them to really be strong in just up to 5. Basically, can they count on one finger? Or on one hand? Can they add on one hand? So that if they have 2, can they add 2 more? And can they see all of that? Then the next is up to 10, then up to 20, up to 100. And in that first go at going up to 100, you're not doing the second number that they're adding is still a single digit number. So it would be a 2-digit number plus a 1-digit number, like 73 plus 5. So they're understanding how to go from 73 up to 5 more, but they don't have to understand, they're not trying to count 20 over 20 numbers or trying to understand about regrouping just yet. And along the way in this process, you'll also be introducing them to the concept of multiple add-ins, which means, adding 3 numbers together or 4 numbers together or 5 numbers together. So they're having multiple instead of just 2 numbers that we usually think about. And as I mentioned, we always start any math instruction, we want to start with concrete, giving them physical objects to count. So this can be little pieces of cereal as they're eating breakfast. It can be carrots as they're eating lunch. It can be the houses that as you pass by, you say, oh, there's 4 houses on this side and 4 houses on that side. And how many houses is that all together? It can be the number of birds that you see. It's kind of like the next level of counting. So if you've been counting with your little kids and then you're adding in, okay, well, we saw 2 yesterday and we saw 2 more today. How many is that all together? And then they're combining that, right? So they're just seeing the next evolution of counting, which is addition. Once you've moved on from the concrete, not necessarily moved on, but the next level from the concrete is pictorial, that they can look at a picture and talk about the addition within that picture. And then it's into the abstract. This is where this is where you're getting just the numbers and symbols, just 2 plus 2, just written out as an algorithm, and they're figuring out. Then they have to interpret that. They have to know what a 2 really means. They have to know what that plus means. They have to know what the other 2 means. And this is where you're going to be supporting that abstract with concrete objects or pictures representing what's happening. So we've practiced with the concrete and the pictorial, and then we're coming back to those as we introduce that abstract concept. We can't just assume that kids know what 3 plus 2 means. And even when they've mastered all of that, now you introduce them to 73 plus 5. We can't assume that they know what that really means and what that really looks like. We need to give them a chance to actually have 73 of something and add 5 more. And they might want to start back at 1 with their counting. And if they do, it's okay. You want to move them away from that by just saying, oh, but how many were here? And what's after 73? 74, 75. So you can kind of model it, but don't stop them right away. Let them do it a few times before you start. Can I show you a little bit of a shortcut? Let's think about that. And as you're going, use stories. Those stories are going to make it so that when they're presented with a word problem, it's not a big deal. They're used to numbers being part of a story. And it also gives relevance to what's happening, right? If we're always just doing straight algorithms, it can lose its real meaning of what is the purpose of this? Why do we solve these kinds of problems? What is it? What's the use? So those word problems can actually give it its use and its purpose. Okay, then we're getting into multiple digit addition. So now we're going to be working on like 2-digit plus 2-digit or 3-digit plus 2 or 3-digit. Initially, with no regrouping. You're just giving them the idea of, and again, with concrete objects, they're working through adding those ones together and adding those tens together. And at first, they don't have to regroup anything. Later, they'll then start to realize that they've got too many ones. But again, when it's concrete, so one thing that I use is, and I should have brought it, but it's just a little frame that has 9 spots in the ones column and 9 spots in the tens column. And so if you fill up all 9 spots, nothing else fits there. And then the kids can see that, oh, it's too big. It has to, and then it can go over into the tens side. And then there can be 10 tens or 9 tens before that. There's too many and it has to go over to the hundreds. So just something like that can help them really see that I only have spots for 9 in this column. I can't go over that. And if I do, it's okay. It just means that I need to regroup and put them over into the tens column. So a lot of us were told carrying the 1. The more common term now is regrouping. And it's a different way of thinking about it because it's not about just carrying a 1 or even carrying 1 10. It's regrouping the numbers so that you've got the tens and ones separated, right? You had a group of too many and you're regrouping it. So again, it's kind of going back to the concrete and really making sure kids understand that number sense of what's really happening. You can also show this pictorially. There's going to be ways to just draw this out. Some people just use like a stick to represent a group of 10. One thing I've failed to mention with the concrete that's really useful is the base 10 blocks. So it's like the tiny little cubes and then the rods that have 10 and then the little plates that have 100, 10 by 10. And then the big cube that represents 1,000, it's 10 by 10 by 10. And there's a similar version in the Montessori materials that are called the golden beads. So they similarly, it's like 1 bead, a stick of 10 beads, a plate of 10 by 10 for the 100 beads, and then a big cube of 10 by 10 by 10 for the thousands place. So those are always great to have as a representation of what's happening. And you can then see, oh, it's, too big. It's, my ones are bigger than this 10. So I need to trade some out and regroup into tens and ones. Okay, so then our next level up is decimals. With decimals, we're starting pretty simple with maybe just one decimal place, but two numbers that both have just one decimal place. So you want to have the same amount in both, like 5.2 plus 2.3. And they're needing to really understand what that is. And really, I shouldn't be saying it the way I just did. It should be 5 and 3/10 plus 3 and 2/10, or whatever number I had said. What we're wanting them to really understand is that that decimal point was always there before. We just didn't see it. Everything right next to it on the left side of the decimal represents the ones place, and then the tens and hundreds. It's always what we've been looking at is that way. And then on this side, it's getting smaller and smaller and smaller. It's getting into tenths and hundredths. They're going to need to spend a lot of time with decimals. Again, think about those pre-adding skills I was talking about. As we keep up-leveling the addition, there's more things that they need to know before they can work with the number. They need to understand what a decimal is in a very concrete and real way before they start manipulating it and adding the decimals together. Once they really understand what a decimal is, it's going to be easy for them to add it together pretty quickly. But they really have to understand it, because it's really easy, especially if you write out the numbers horizontally, like 5 and 3/10 plus 2 and 37/100. If they try to just line it up along the right like they've always done, now their decimal points are out of alignment. And they're going to have to really understand we're adding ones and ones and tenths and tenths. We've got to line that up. So showing them that is really, really important. And if they've practiced with what decimals really mean and understand that, it'll be a lot easier for them. One great thing to really enforce decimals and a lot of other math concepts is money. Really giving them a lot of experience with coins and money, and recognizing that $1 is 1, whereas then you've got the decimal, the tenths, right? Those dimes are tenths. Those pennies are hundredths. They can really see that and play with that, and you can use that to represent the numbers that they're working with. I talked about the vertical and horizontal, place value. And again, you can represent things in that concrete with those hundreds, the base 10 blocks that I was mentioning. The one thing you might want to do is buy a second set that's a different color than the first set, because it can be confusing for kids if they've played with those base 10 blocks as ones, tens, hundreds, thousands, and now all of a sudden you're calling this one and this tenths and this hundredths and this thousandths, and especially if you switch up which one you're doing, like, one time the 100 plate, maybe that's your one whole, and then the sticks are tenths and the little cubes are hundredths, or maybe your big 1,000 cube is your one whole, and your plates are tenths, and your rods are hundredths, and the cubes are thousandths. It can be confusing for kids to go back and forth through that. It's good for them to do it and to really get flexible in their thinking and think, well, if this is a whole, how many of this next piece make that up? So that must be my tenth, that must be my hundredth. And they can see what those pieces are. It's good for them to really play with that and spend a lot of time in the concrete understanding that before trying to move into, again, adding them, subtract them, manipulating those numbers. But sometimes having a different color of number of base 10 blocks can help them just be like, no, this is for this concept. I understand. These are my tenths. So just a thought. Okay. Fractions is another major concept. And usually fractions, you start introducing it in around third grade. Second to third grade, they start introducing what fractions are, and then they really need to understand it in a very real way by fourth grade, typically. But the bigger point is you've got to understand what fractions are. The fractions are so confusing to kids. So confusing. Because they've got these two numbers, and they're trying to understand what each of those numbers means. And I've had so many students who I think completely understand it. They're super good working with it. And then some tiny little bit changes, and all of a sudden they're giving me these answers that don't make any sense. And it lets me know they never really understood it. They could perform the task, but they didn't really understand what they were supposed to be doing. So we want to give lots and lots of time in the concrete with fractions, lots and lots and lots. Like, you just can't do too much of this. You can get fraction tiles. So it'll be like a bar, or they also have like pie-shaped ones. And you might want to get some of each just to have all of it. It can also be good to have several sets so that when you get into adding thirds and fourths and it's going to equal more than one, that you have enough of everything and you can reshape it into multiple of them. So it can be helpful to have more than one set to when you're working with those fraction tiles. But either way, if you have the fraction tiles, there's so much to it. The fraction tiles will usually say on them like what the value of the one piece is, like 1/3. So if they're looking for 2/3, I've had so many kids try to take the halves because those have a 2 on them. And it's going back, they need so much time with it to really understand what is 2/3. It's 2 1/3. The 1/3 is just telling us the size of the piece. They really have to understand that. One thing I do a lot with when we get into adding fractions, after they're really solid in understanding what a fraction is, we get into adding fractions, and I'll say things like, if it's 3/4 plus 3/4, I'll just say 2 of each. 3/4 plus 3/4. I will say, think of it as 3 apples plus 3 apples. I want them to think about that fourth as just the name of the size of the piece. The fourth can't change. So I'm doing 3/4 plus 3/4 is 6/4. 3 apples plus 3 apples is 6 apples, right? So it needs to be consistent. That's how we're going to remind them that denominator doesn't change. And your kid might be brilliant with multiplication and division. You never want to teach addition, subtraction, multiplication, division of fractions all at the same time or very close together. They need to be super solid. And you can even start with multiplication if you want. You don't have to start with adding fractions. People just do, typically. But start with either multiplying or adding. Get super, super, super solid in that before moving into the division or subtraction, whichever, depending on which one you started with. And then make sure they're super solid in that. Go on to something completely unrelated before getting into the opposite, the addition, subtraction, or multiplication, division. So for example, addition. We're doing addition, fractions, super solid, tons of concrete, putting it together. We're good. I feel really confident that we know what we're doing. Then we're going to get into the subtraction, super solid. Subtraction isn't too much different from addition, so it should go a little bit faster. We're good. Got it. Then I'm going to go work on geometry and some review of earlier concepts, decimals, whatever other things I want to work on. And I'll keep throwing in some addition and subtraction of fractions as practice. Then much later, multiplication, division of fractions. too often I see it all together. There'll be like a 5th grade math book that'll be like addition, subtraction, multiplication, division, all in one chapter. It's so confusing to kids because the way the numbers work is so different. And their brains trying to wrap their head around what a fraction really is hard. So we really want to make sure they have the time to explore that and figure that out. So please keep those separate. And then with that, you're starting with less than 1 of the same denominator. Like 1/8 plus 3/8 equals. And then you can also get into equivalent fractions as a good thing to keep going back to and have them in the habit of that. Then you'll start doing more than 1. Then when they're really good with more and less than 1 with the same denominator, then you're going to do the same thing with different denominators where they're having to figure out those equivalent fractions and get those number tiles back out, those fraction tiles back out. If you already thought they had it mastered, they don't. Almost guaranteed. They're always struggling through this. It's such a hard concept for so many kids. So we're going to get those fraction tiles back out and have them really look at what else is 2/3 equal to. What else is 3/4 equal to? What are both 2/3 and 3/4? What size can both of those use? What size do they have in common? Then after they're seeing it, feeling it, touching it, cutting things, you can have them cutting things perfectly evenly. Legos, you can look up Lego fractions, and there'll be some things on like Pinterest that will show you how to use the Legos to teach fractions. Anything like that where you're looking at how do I actually make these the same size pieces? I'm going to have more of those pieces because they're cut into tinier bits, right? We're trying to really get them to see how that works. So when they're really solid with that, and then getting those equivalent fractions, and then adding those. So with less than 1, then with more than 1, understanding how to change equivalent improper fractions, the fraction greater than 1 into a mixed number, where you have the whole number like 3 1/2. It gets to be a lot, and playing with those fraction tiles, and this is where having more than one set of fraction tiles is helpful because usually it's designed that everything equals 1. But if you want to be able to have like 2 wholes or more than 12 twelfths, you need more than one set. So having more than one set can be helpful. And you can even like print these out. You don't have to buy the actual like plastic tiles or even wood ones I've seen. You can actually get a printable and cut them out and print them out that way and use those. Anything that is, as long as you just have to make sure you're cutting it really exactly so the kids can actually see the exact size comparison. But they're a great tool to be using. Okay. One other thing I added onto here is algebraic addition. And this is something that kind of can get integrated into every step as we go through all of those other levels I was talking about. You can have an algebraic version or practice after they've mastered every other set. So as soon as a kid is really solid with adding numbers less than 10, they can do 2 plus 7 all the time, super easy for them, then you're going to want to throw in something like, 2 plus and a star equals 5. Well, 2 plus star equals 5. What does the star equal? And they're having to think about that. And it's going to be a little different for them to try to figure out, what does that mean? But it's also going to give you a clue as to how well they really mastered that understanding and that concept. So I would encourage you to do it earlier than you think that you maybe should, because a lot of us weren't introduced to this at all until like high school. But there's really no reason why a very young child can't do an algebraic version of what they're already doing, that they've already mastered, I should say. I would not start with this. I don't want to introduce fractions with algebraic formulas that have fractions. I'm starting with concrete. I'm going into pictorial. I'm going to abstract. Then I might add in algebra as part of that abstract level and getting them to really understand it. And I'm going to be supporting it with pictures and concrete objects and really showing, well, I'm starting with 2, and at the end I have 5. So how many did I have to add? Oh, so the star must equal 3, right? So going through all of that and having them really, really look at that and understand it. I think, yeah. So there's examples of all of that on the website if you want to check that out. So that was a big one. Your takeaway for today is that adding and all math should be approached concrete first, then pictorial, and then abstract. And go slow. You cannot spend too much time in that concrete pictorial and keep having those things available, the concrete manipulatives, the pictures, the pencil paper, scratch paper. Be quick to go back to that if there's any struggle when they're practicing the abstract stuff. And also make sure you're incorporating stories along the way at every level and making all of that math very real for your kids. You're going to find a lot more success that way as things get more complicated. And if you want any more in-depth support and help in how to teach your child, you can email me, Kimberlyn@decodinglearningdifferences.com. You can also let me know any math strategies you like when you're teaching addition to your kids. Again, Kimberlyn@decodinglearningdifferences.com. And you can also find me at yourparenthelp.com. I hope you have a fabulous day.